A simply supported load carrying a load P and P at the same distance A from the support. This we are doing in lab as 2-point problem. We are in lab we are giving a pure bending case using this experiment. Okay, so this is a 2-point problem. Here two loads are given at a distance of A from the supports. So we will have a reaction of P and P here if we check the symmetry. Okay, here moment will be 0 at A and B because they are hinges and rollers. So we will have something like see the elastic curve will be something like this. So see the bending moment will also be or like similar shape. Okay, because this is a sagging case, we will have a bending moment diagram of positive value or positive sign. So we will first draw the shear force diagram. Okay, here the value P load is moving up. So P value positive till it reaches here when the P value pushes it down. So here it is P value. So it pushes down means it will raise the zero here. Okay, from here to here there is no load in order to increase or decrease it from zero value. So till it reaches here. At this point, the P pushes it down side. Okay, so it moves downside. The value will be P. So because the left portion is pushing it downwards, it will be negative. So till it will move like this till it reaches here. When out P force will push it upside. So we are just tracing the paths of the loads. Okay, so this is our shear force diagram. Now we'll have to draw the bending moment diagram. We know that bending moment diagram will be positive. We'll have to draw it in the top side. So we'll have see here P's. We'll have to check it. Okay, here the moment is 0 because it is a hinge here, and here also the moment is 0 because it is a roller there. So after that, P into this distance, P into A, this much moment, because this is the parallel to the x-axis, this will be a straight line inclined to x-axis. This is x raised to 0 variation means this is x raised to 1 variation. So we will have PA moment here. Okay, now there is no other force till it reaches here. You can check it. Okay, I know that because suppose you take a section somewhere here, then you can calculate the net value of moment will be PA itself. Okay, till it reach here. Then at this point also we'll have PA value. Now after that you can just directly join it here. Okay, otherwise from this side also if you check this section, see P into this distance A, it will give a value of PA here, and here because it's a roller you'll have 0 value, so we just have to join it by an inclined straight line, so it will be positive inside. So see in this section here, in this particular section we'll have a case of pure bending. Shear force is 0 in this section. This is a case of pure bending occurring between these two portions. Okay, so that is there. Now the next question. A simply supported beam carrying a uniformly varying load. Okay, this is somewhat complicated related to the other questions. See, like this it is acting. We have W per meter length. This total distance is L. Okay, so we'll have A here, P here. Let me simplify this so that I get, let me simplify this case so that I get the reaction. Okay, see this load, I can put it as W per length into L by 2 will give you the total load. It just means like this. See, we are taking UDL, you can represent UDL like this also. So the W per length in this distance means the total load is WL. So, but this triangle means that this is half of this. So we will have WL by 2 as the total load. Okay, or otherwise in other way also this is a triangle. So half into base into height will give the total value. So half into the total area will give you the load. So half into length into W per length. So that will be WL by 2. In both the ways you can calculate the total load as WL by 2. Okay. So we will have a total load of WL by 2 acting at the centroid. See, the centroid of this triangle will lie at a distance of 2L by 3 from this. So 2L by 3 here, a value of WL by 2, and here this distance will be L by 2. So this is a case like PB by L and PA by L force X reactions. So WL by 2 into see here L by 2, L by 2 here. Also WL by 2 into 2L by 3 here. So that will be WL by uh, hmm, this is sorry, this is L by 3 na. This will be L by 3. Okay, so we'll have this is L by 3. So WL by 6. Here it will be WL by 3. Okay, this will be the reactions. So this method I just used in order to find the reactions. Okay, now you know the reactions here. This is WL by 6 and this is WL by 3. Otherwise, using this also, the triangle also, you can find out. I found this as very simple, so I use this method. Okay, so that is the now. See, you have a condition like this. Now see here it is a hinge and roller. So the moment will be zero at these points. So we know that it will bend somewhat like this. So this will be a case like this it will bend. So we will have a sagging case here. So we know that the bending moment will be positive. Okay. Now we will have to draw the shear force diagram and bending moment diagram. Okay, now what will happen? See, this is much complicated situation. We'll have to find where bending moment is maximum. So this is a uniformly varying load means that that this is of x raised to 1 variation. So you know that the shear force diagram will vary as x square and bending moment diagram will vary as x cube, that is cubic parabola. Okay, so we'll have to just make find out the point where bending moment diagram is maximum. In that bending moment diagram is maximum means shear force will be to 0 at that point. So we will put a section at x distance from here, support A. In that section, we assume that bending moment is maximum or shear force is 0. Bending moment is maximum or shear force is 0 means that d of differential of bending moment with respect to this x will be 0. Okay, that point shear force will be 0. That is d of bending moment by dx will give you shear force. This shear force is 0. That means that bending moment is maximum. Okay, so we'll have to find that the value here. Okay, at the distance of x from the support. Okay, so we are drawing the section of that. See, we are drawing the section like this at x distance. We know that here it is WL by 6, and here the triangle is like this, W per length in L distance. So at x distance, it will be having a value of Wx by L. Okay, from similar triangles, you can find it easily. So here the value will be Wx by L. So that is theirs. Now we have to find the total moment here at this section. Okay, let us name it as x6, the section x6. So the moment here will be WL by 6 into perpendicular distance x minus, see the load will be like this. So we are taking this direction. Here the direction is like this. Here it is opposite. So minus W x by L. This is the value. This is like a triangle. So we'll have to put it like half into Wx by L into the distance x. This will become the total load. That is, the area of this will give you the total area of this will give you the total load into centroidal distance. See here, there in this portion the centroid will be like, here it will be 2x by 3, and here this will be x by 3. So the centroid of this will be at here at a distance of x by 3 from the section. So into x by 3 we'll have to put. So WLx by 6 minus, that will be Wx cube by 6L. This will be the bending moment at this section. So we'll have d of bending moment by dx is equal to 0. That is, shear force is equal to 0 in order to find bending moment as maximum. So we will have differentiating this value. Okay, so WL by 6 minus x cube means 3x square, 3wx square by 6L. So this will become 2. That is equal to 0. So we will have x is equal to, solving this, we will have x is equal to L by root 3. This will be the value of x. So at x is equal to L by root 3, where L is the total length of the beam. At that point, we will have bending moment maximum or shear force 0. Okay, so now this is our case. At L by root 3, we will have bending moment maximum, and here we have a force of WL by 6. Here there is a force of WL by 3. The total is W per length. The total length is L. Okay, this is our case now. Okay, so we will have M maximum, we will have to find out the value of M maximum. See, this is our bending moment. So solving that, we will get the putting x is equal to L by root 3, you will get the maximum value of bending moment in that section. That is this section x6, which is a distance of L by root 3. Okay, so you can solve this one. WL into L by root 3 into 6 minus W by 6L into x cube. Instead of x cube, it will be L by root 3 whole cube. So solving that, you will get a bending moment maximum as WL square by 9 root 3. Okay, so that will be the value there. Okay, now we'll have to solve this. We'll have to draw the shear force diagram and bending moment diagram. So this side is positive, this side is negative. So see the portion, this portion is moving upward. So WL by 6, and this will be positive. So till it reaches here where shear force is 0 here. So this will be x raised to 1, x raised to 1 variation means this will be square variation. So we know that this is a square parabola. So it will go like this till it reaches 0 value here. Then we will have a downward force acting. So it is going to go like this till it reaches a value of, sorry, till it reaches, it will go like this till it reaches a value of WL by 3, and it will, here there is a force WL by 3 that will put it like this. Okay, this will be negative. This is our case. See my like this. Okay, so that is the now bending moment diagram. See, this is a sagging case, so bending moment diagram is always positive. We represent it upside. Okay, so here we have 0 value and here we have 0 value, and we will have a maximum value at this point, which is a distance of L by root 3 from this A point. Okay, so at this particular point, we have a maximum value of WL square by 9 root 3, which we have already found out, and this will be like a cubic parabola, like this. Like this we will draw. Okay, this value is WL square by 9 root 3. This will be positive. Okay, so that is it, we have discussed many problems. These all are very simple problems. This is everything regarding shear force diagram and bending moment diagram. You can, if you do these much problems, you'll be very clear about the concept of this. And I will have a next section on various IAs and various examination questions regarding bending moment diagram and shear force diagram. Do follow that also, then you will be very much clear about these concepts. Okay, so if you haven't subscribed to my channel, please do subscribe, and please press the bell icon, and please do share these videos with your friends also. Okay, thank you.